What is going on, guys? Welcome back. This video is going to be a simple turtle crash course in Python. This is a Python module that we can use to interactively learn Python. It is especially a module that can be used by beginners and by younger programmers to understand programming principles in a graphical way. So let us get right into it.
It's not a game, it's a rich thing.
Alright, so as I already mentioned, Turtle is a library that is mainly used by beginners and by younger programmers to get started with coding, to get in touch with coding, to practice, to study principles in a graphical way. It's not necessarily a library that you would use in your actual projects or applications, in production or in an actual software. It's mainly for studying, practicing, and visualizing whatever you're doing in your code. And it is part of the core Python stack, so you don't have to install anything. You can just say import turtle and you can use it right away. And we're going to start now with a simple example of drawing a simple line. So we're going to say turtle dot, and we're going to set a color first. We can define a color by saying turtle dot color and passing a color name. So let's go with red for the beginning. And then let's say turtle dot forward and a distance. Let's say 100 is going to be the distance. And then last but not least, so that we can actually see the graph in the end, we're going to say turtle dot done, because otherwise it's going to draw the line and disappear. With done, we keep the result on the screen. So when I run this, you can see it drew a red line to the right, because right is the default direction. And that is essentially what this line of code here did. So this set the turtle to red. This move the turtle forward into the direction that it was looking at, 100 units forward. I don't know if that's pixels or some turtle unit or something, but essentially 100 instances forward. So we can now do something else. We can say, okay, turtle dot left, and here we don't specify a distance, we specify an angle. So we can say, for example, okay, we now went 100 instances forward, let's go 90 degrees left. So I can do turtle left 90, and I can do turtle forward again, and I can pass a distance of 100 here. And when I do this, you can see it went right and then up, because from this direction, 90 degrees to the left is this direction, and 90 degrees again to the left would be this direction. And of course, if I pass something else, like for example, I don't know, let's go with 70, it's going to be diagonal. It's not going to be exactly straight, so you can see it goes here to the upper right. This is the basic idea of turtle. You can give commands to this turtle instance, which is the pointer that we see on the screen. Of course, we can also change the icon and all that. We can make it an actual turtle. But essentially, you just say, okay, go forward, go left, go right, fill in, change the color, do whatever you want to do, fill up a polygon or something like that. Do whatever you want to do with these lines of code, right? So you can specify algorithms and you can visualize them using turtle. So you can write the logic of your algorithm, and then you can use turtle to actually see what you're doing, and you can practice and study programming that way. And we're going to look at a couple of examples here, but let me just briefly show you how we can also fill the shapes that we draw. So let's do something like maybe fill a square or something like that. Let's say the turtle color is going to be red and blue, so it's going to fill with blue and the outline is going to be red. And here we're going to just say turtle dot forward 200, then turtle dot left 90, and we're going to do that 4 times, and we don't need to do the last left, because then we're already not full circle but full square. And once we have that, we want to fill that. So if I do it right now, there won't be any filling. You can see that the pointer has a blue color inside of it, but it doesn't fill anything here. If we want to do the filling, what we have to do is we have to say turtle dot begin fill, and once we're done with the actual shape, we can say turtle dot end fill. And you can see that then it fills up this red rectangle here, this red square here with blue color. Yeah, so that's a very basic example here. Now, we can also put that into a function and automate it. So we can go ahead, take this code here and put it into a function. So we can do something like def draw square, and then we can say we want to have a size for this square, and then we can just do this code here and replace 200 by size. So we can do that in each of those forward calls here. And you can either have the begin and end fill inside of the function, or you can do it outside of the function. So for example, we can take this down here and say, okay, begin fill, end fill, draw square of size 200. So basically the same result. There you go. And we can now say something else. We can say, okay, we want the turtle to go to a different point. Now the problem is, what do we do if we want to move the turtle but we don't want to draw? So let's say I do something like this. I draw the square, and then what I want to do is I want to say, okay, turtle dot forward and go 300 units down, I think is the direction in the end, and then start a new square, right? So I can copy this here and do the same thing. So this would work, of course. I think it's outside of the screen. Maybe let's pick a different number. Let's go with 400, not 400, forward, I don't know, 200 or something. But essentially you can see that, maybe I can maximize the window. There you go. You can see that there is a line here. Maybe we don't want to have the line. Maybe we want to move the turtle without drawing while we are moving the turtle, which is the default, right? And for that, we have a simple method called pen up. So we can say, actually, before we do that, we can say turtle.pen up. And you're going to see that it's not going to draw, but of course we want it to draw later on. So now it does that. It goes down, it does the square, but we don't see anything. Oh, actually we do see anything, something. Probably because of the begin fill, but we can also say pen down to go back to drawing. So we say pen up, pick up the pen, don't draw, move to a certain direction, go down with the pen again, and then we're going to also see the drawing progress down here. There you go. So this is how you can do that. By the way, what you can also do is you don't have to use the turtle module as a whole. You can also create an instance. So instead of doing all this here, we could also say, we could say t equals turtle.turtle with a capital T. This is the instance now. And then I would say something like t.color is red and blue. And here I could do something like draw square, and I could pass a turtle underscore object. And I could replace the turtle here with a turtle object. And I can do that for all these instances here. And for this one here as well, and for this one here, and for this one, this one, this one, this one. Oh, sorry. Of course, here we don't have the turtle object because that's the parameter of this function. Here we have t, which is a turtle from above. So we do it like that. So now we have this turtle function here, this turtle instance here. We set the color, and here to that function we have to pass it. You can see that parameters are missing. We can pass t here as the object, and t is going to do the job. So this is also something that we can do. I think though we need to say turtle done because that's the module function here. But you can see the result is the same. Everything works the same way, even though we're not targeting the module directly, because now we're working with an instance here that we created. So that's quite simple. Let's move on to some more advanced coloring. Maybe we want to keep, do we want to keep that function? I don't know. Let's just remove it for now. What we can do here is, or actually let's keep it, so we don't have to write the whole code again. So this is still our square function, but maybe we want to do something else. We want to color the background. We don't just want to set the color of the turtle. For that, of course, we also have some functions. So we can say or actually turtle.getScreen. This gives us the screen object that we're working on, the whole screen, and we can set the background color of that screen. So we can say BG color, and I can pass a color like blue, for example, or of course you can also pass a hex number, so a hex code of a color. So you can say, for example, if I want to have a yellow, that would be a mixture of red and green, or is it? I think red and green is yellow, right? So FFFF00 should be yellow in the end. And of course, we need to say turtle done in the end. Yeah, there you go. So now we have a yellow background. So this is how you can set the background. You can also set the turtle color again. In this case, I'm not sure if we can do that with the instance here as well. Maybe this works. Yeah, it works. And then we can change the color of that. We can do all sorts of things. We can also try to draw a more fancy shape. I think this should be a star if we do it like that. So if I say for empty control variable in range 5, and then I do turtle, or in this case t dot forward, and I start with, I mean, the size is not really that important. Let's do 100, but the angle is, as far as I remember, 216 degrees. That should result in a star, if I'm not mistaken. Let's see. Okay, this is a bit too... Oh, this is forward. That's the reason. There you go. This results in a star, so this is a simple shape. And you now might understand why this is a library for beginners. This is not something useful in your code, but you can play around with mathematics, with geometry, and with the programming principles like loops, like if statements, like functions, and see graphic results. You can see if the thing that you want to achieve works because you get graphical feedback. This is essentially what you want to do. And now we can take that and combine it with another principle. So maybe you learned about random numbers, about the random module in Python. You want to combine it with your turtle knowledge to get some feedback. So what you can do is you can get that here. You can say this is the draw star function. I want to have a turtle object here, and I want to have a size. And then I'm going to do exactly that. So this is going to be the turtle object. This is going to be the turtle object as well. And then this is going to be the size. And what we want to do is we want to set the background now, let's say to 0, 0, 0, 0, 0, 0, so completely black. And we want to draw multiple random stars. So random sizes, random positions. We want to have a night sky full of stars, right? And this is something that beginners might want to try out. How do I do that? How do I do that with the knowledge that I already have? I know how to use random. I know how to use loops. I know how to use if statements and functions. How do I do that? You can do something like this. You can say for, again, a counter variable here, a control variable that we don't name. In range, let's say we want to have 50 stars. You can do something like the x and y coordinates of the star that we want to draw are going to be random. So we're going to say we need to import random first. Import random. Going to be random dot rand int, and we're going to say from negative 300 up until 300. We need that 2 times. Come on. We need that 2 times. So random rand int negative 300, 300. And the reason we do negative 300 up until 300 is because the center of the screen is 0, 0. And when you go to the left or up, it's negative. And when you go down or right, it's positive. So the center is not, so 0 is not the upper left corner. 0 is the center. That is that. And what we do now is we say, okay, give me the instance, give me the t instance that we have here, and say pen up. So we don't want to draw while doing that. We just want to navigate to a certain point. We go to that point. So we say t go to, which is another turtle function. And we go to x and y, which are the coordinates that we randomly generated. And now we say draw star, or actually we need first to say pen down, then begin fill, and then t end fill. And in between, we're going to say draw star t, and we can say random dot rand int, and we're going to say something like 525 is going to be the range for the size here. And we're going to do that 50 times. And this is going to create a night sky full of stars. We have a background that is black. Now maybe we want to have a different color here for the actual turtle. So maybe we want to say color. The outline should be white and the fill color should be yellow. And that should actually produce what we're looking for. There you go. So we get different stars, different sizes, different positions, completely randomly generated. And by the way, if you want to speed up this visualization, if you don't want to wait so long, you can say t speed. And I think we can do something like 10 to speed this up a little bit. There you go. You can see it works way faster. We have small stars, we have big stars. And I think if we do something like 200 here, it should be quite fast. I'm not sure what the limit is, but you can see how fast it draws the stars. So that's one thing that you can do as well. Those are just examples, right? So I don't want you to do the same thing. I'm just saying when you're learning about Python, when you're a beginner programmer, you might learn about loops. You might learn about if statements. You might learn about certain operators. You might learn about functions. You might learn about different constructs that you want to try out. And if your goal is to do that, which I just showed you, to randomly draw some stars visually, you have to use loops, you have to use the random module, and in this case we also use the function. So maybe you can practice it using Turtle and you get visual feedback. You don't need anyone to tell you that you did it right if you get what you get, right? So you see this is exactly what you wanted and you get it, so you get visual feedback. This is why this library is quite useful when you learn to program for the first time. What else can we do? We can of course also clear the screen. So if we want to do something new, we can say t.clear to clear basically everything we did so we can start again. So if I run this now, let's just decrease the number so we don't have to wait that long every time. Let's just do 10 here. Once it's done, we can clear the screen. There you go, we reset it. Everything's gone. The background color, of course, is still black because we didn't change it. Then another thing that I want to show you is that you can also change the direction without rotating to left or right. So we don't have to say T right or T left. You can also say T set heading, and set heading basically means go to that angle, go to that direction. And for example, if you pass 0, it's going to be east. If you pass 90, it's going to be north. Essentially, the default direction is to the right, so to the east, and this is 0. If you go 90 upwards, it's going to be north, 180 is going to be west, and 270 is going to be south. So this is how you can set the direction independent of where you are, because maybe you don't know where you are, and if you say left 90, you're not going to end up where you want to end up. If you say set heading 90, you're going to end up looking into the north direction. One more thing that I want to show you here also, this is quite cool, a little bit more advanced, is you can save shapes. So the same way you can say begin fill and begin fill and end fill, you can do the same thing with begin poly and end poly to register certain shapes. So for example, let's start with a very simple square, or let's do a simple square here. Let's get rid of all this here. And let's say now that our turtle, what we want to do is we want to say t.begin poly, t.end poly, and then we want to say for counter variable in range 4. We just want to say t.forward 100 and then t.left 90. This is just going to produce a simple square, as you can see here. But let's say we want to now take this and register it as a shape called square. And of course, for a square, it's not that meaningful, but maybe you have some complex stars, some complex patterns that you want to have a name for that you can just call and say, draw that shape, and then it does that. So if you want to do that, you basically do the same thing here. You do begin poly, end poly, and then what you do is you say, okay, p equals, or whatever you want to call it, p equals turtle dot get underscore poly. This is going to get the current polygon, and it's going to say, and it's going to, we're going to be able to register this object with a name. So we can say turtle dot register shape, and we can pass a name. We can say this is the square, and we want to register with this name, this polygon. So we have this object here, we register it here with the name square, and the next thing that I can do is I can go ahead and use that name to draw it again. So I can say, actually, did this work? Or did I have a problem with this one? Bad arguments for register shape. Why is that? Let me just check this here with my prepared code. We have begin poly, we draw it, we say end poly, turtle get poly, then turtle register shape square. Oh, the problem is of course that we say turtle and we use t up here. So I think either we have to use only turtle or only t. I'm not sure if turtle is gonna work in this case. No, I think we need to use turtle all the time. Okay, so let's get rid of this and let's say turtle. And then let's say turtle here again and here, and not like this, like this. There you go. There you go. There you go. I think this should work now. There you go. It doesn't crash. Now we can use turtle again to draw that shape. So we can do something like turtle, or let's first of all move somewhere else. Let's say turtle dot go to, and let's go negative 100 or negative 300, negative 200 is fine. And then what we want to do is we want to say turtle dot shape, and we just passed the string square now that we saved before, that we registered before, and you will see that it moves there and draws the square. In this case also it fills it up. But yeah, this is kind of cool. You can register shapes, you can recall them, you can reuse them. Yeah, those are the basics. So this is the essential stuff that you can do here. The rest of the video is going to be about examples. So I'm going to show you examples of fancy figures that we can draw. And I want to start with a simple star here. So a little bit more complicated, not necessarily the star that we saw before with just 5 iterations, but one with 36 iterations. So what we're going to do here is we're going to say turtle.getScreen. Or actually, we're going to do this one afterwards. We're going to do, first of all, the star. We're going to do def draw underscore star xy. So we're going to pass coordinates, and we're going to say turtle.pen up so that we don't draw. Turtle.go to x and y. Turtle.pen down to start drawing again. And then we're going to say turtle.color red, yellow. And then we're going to say turtle.begin fill, turtle.end fill. And in between, we're going to run our logic. It's going to be for counter variable here in range, as I said, 36. And we're going to do the following. We're going to say turtle dot forward. In this case, we're going to use 150 as a size here. And we're going to say turtle dot left 170. So this is a degree that will go full, not full circle, but full star again to the beginning in 36 iterations. And if we do that now, and we say now, in this case, turtle dot speed is 200 so that we can speed up the animation, we can now just go ahead and say draw star, I don't know, 0, 0 directly in the middle, and then turtle dot done. This is quite a fancy figure. There you go. This is what it looks like. But what I actually wanted to show you here is that we can make Turtle actually interactive. So we can actually say, okay, we want to draw these figures when we click on certain positions on the screen. So we want to do the following thing. We want to say turtle.getScreen, and we want to say onClick is going to call turtle.goTo. So what we're doing now is we're basically saying, okay, when I do the onClick, we're going to trigger the turtle.goTo function, and this is going to go to that point. This is the simple version. If we now replace the goTo with the draw star, this is going to do exactly what we did before, but it's going to draw the star at the position. So if we do it just like that, in this case, it draws a star. And if I click somewhere, you can see that the turtle goes to that position because we bound the goTo function to the mouse click. So it gets the coordinates that we're currently at. Whenever we do the onClick, it passes an X and Y coordinate. So if I click here, it's going to pass the respective coordinates to the goTo function and execute it. If I now replace the goTo with the draw star function down here, so after the function, I'm going to say turtle getScreen onClick is going to be draw star. Then you're going to see that the same thing is going to happen. We're going to pass X and Y to the function. It's going to be executed. So I click here, it draws the star. I click here, draws it. And I can do that, and you can see that it's going to have also some problems because if I interfere, so if I click all the time, it's going to get buggy because it does certain things here that it shouldn't be doing. But essentially, you can see it makes it interactive, right? This is kind of cool. This is a little bit more advanced when it comes to the turtle module. And last but not least, I want to show you something. This is not my example. I didn't come up with it, but it's one that is used in the internet quite often. It's a fancy rainbow shape that you can, looks like a spiral, a little bit trippy. And it's a nice thing that we can plot here for the end of this video. We can say the colors that we want to use are red, yellow, green, blue, purple, and orange. I think we should only have 6 colors, right? I think that's right. And then what we do is we say, okay, the turtle is going to have a speed of 500. And we're going to say the turtle is going to have a background color, so BG color of black. And then we're going to say in this case, we need the control variable, which is why we're going to give it a name. for x in colors, we're going to say, or actually, no, for x in range 360, what we're going to do is we're going to say that the pen color of our turtle is going to be the colors index x modulo 6, because we have 6 colors. So we're going to use one of the colors with each iteration here, and then what we're going to do is we're going to say the turtle.width is going to be x floor divided by 100 plus 1, and then we're going to say turtle.forward x steps and turtle.left 59. Again, as I said, I didn't come up with this myself. This is something I found on the internet, but it's a quite cool graph here. You can see it gets larger and larger as we go on, and it looks quite interesting. It changes the color, it changes the size, and then we end up with the spiral form here, which is quite nice. And you can come up with other fancy artworks if you want. This is a nice way to practice Python, to practice programming and algorithms. Yeah, this is what you use the turtle module for, and this was a little crash course. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.